Next, we're going to continue with the connection between Cartesian and polar coordinates, now working with equations. So we're going to take the polar equation. In this case, we've got r squared equals 4r sine theta, and we're going to replace it with a Cartesian equation. So I've pulled up the four equations that we're typically going to use, so the connections that we looked at between x's and y's and r's and thetas. So again, I want to convert this to a Cartesian equation. Notice that the r squared I'm going to rewrite as x squared plus y squared, and the 4 just stays. R sine theta I can rewrite as y. So we get x squared plus y squared equals 4y, and we could put a box around this and be done, but what I'd like us to do is identify what this is actually the graph of. This is going to be useful for us as we move forward. So I'm going to pull this 4y over. I get minus 4y equals 0. And now hopefully some of you are starting to see that this is actually the graph of a circle. If you don't see it, that's okay. The next thing we're going to do is complete the square. So completing the square is a technique that you learned back in algebra or pre-calculus, and it's going to allow us to see that this is actually a circle. So the x squared I'm just going to leave by itself. Now the y squared minus 4y, remember your technique for completing the square. So you take the coefficient of y in this case, which is 4, you cut it in half and you get 2, and then you square it, and in this case we get 4 back. So we're going to add 4 to the left-hand side, and now to keep it the same equation, we added 4 to the left, so we've got to add 4 to the right as well. So now our equation becomes x squared plus y squared minus 4y plus 4 equals 4. And so the left-hand side is, if you've done the completing the square correctly, the left-hand side will always factor as we had a minus in front of the 4, so minus, and then whatever number you got here before you squared. So in this case 2, y minus 2 squared. And just check y squared minus 4y plus 4, yes, we did do it correctly. So this is our Cartesian equation, and now I want you to remember this represents the graph of a circle with center 0, 2, and radius 2. So remember the general equation of a circle, we're going to need this later on, is x minus h squared plus y minus k squared equals r squared. So this is the equation of a circle with center hk and radius r. So here we've got center 0, 2 and radius 2. So the key points to focus on for this problem are using our relationships between Cartesian and polar to convert to x squared plus y squared equals 4y, and then this completing the square technique, which we're going to need later on. All right, let's do one more of these conversion problems. So now if we had x squared plus y squared, we could just make that r squared, but it's x squared minus y squared. So x we can replace with r cosine theta, so we get r cosine theta squared minus r sine theta all squared equals 1. We now have a polar equation. We can simplify it a little bit. This becomes r squared cosine squared theta minus r squared sine squared theta equals 1. I can factor out my r squared and get cosine squared theta minus sine squared theta equals 1. And you could use trig identities to simplify that further, but we'll just leave it as it is. You could have just left it in this first form as well. That's fine with me. Again, the point is to use your relationships to convert, in this case, from Cartesian to polar.